learners. In this lecture, we will learn about classification of errors. In the last two lectures, we have learned about the introduction to errors, and we also looked at accuracy and precision while handling a set of data. Errors may be identified from different sources. We can actually classify and systematically study them based on their source, based on their nature. We can classify them. We can classify errors into two broad types. They are called as systematic errors, which is also called as determinate errors, and random errors or indeterminate errors. Systematic errors are non-random. They occur when something is intrinsically wrong in the measurement, which may be due to the faulty instrument, which may be because of the carelessness of the experimenter, or it may also come from a reagent which is not properly working, or an instrument which is not calibrated. On the other hand, we have random or indeterminate errors. In indeterminate errors are often accidental, and sometimes they cannot be avoided at all. Sometimes they may be present as a background noise in several spectral characterizations. So we'll see the different types of systematic or determinate errors. The first type of systematic error that we are going to study is called as an instrumental error. We use different set of instruments in order to carry out different measurements. If you are measuring a volume, we may be using a measuring jar. We may also use a Erlenmeyer flask. Sometimes we'll also be using a burette or pipette. These instrumental errors are non-ideal or due to the non-ideal instrument behavior, or it may also come from the faulty calibrations or use of instrument in inappropriate conditions. All these type of systematic errors may be sourced from faulty instruments like a burette, pipette, or volumetric flask, which is supposed to deliver a particular volume, but it is not delivering that volume. Either it delivers a higher volume or a lower volume. So these differences arise significantly from the temperature at which the glassware is used. The universal temperature at which any experiment that is carried out is called as ambient temperature, which is 25 degrees Celsius. Suppose if the experiment is carried out at 35 degrees Celsius, there may be minor changes in the volume held by these apparatus. So the measurement of volumes using these apparatus may not be accurate. And this results in the instrumental error. Here you see a weighing balance, a normal digital balance that we use in the case of weighing any chemical substance in the laboratory. If you use this instrument without calibration, then errors may come in. Sometimes, if the instrument is having additional impurities like rust, or if the instrument is handled at a higher temperature, it may not give you the accurate weight. These type of errors are usually categorized as instrumental errors. It may also come from electrical fluctuation that happens in the power supply of this weighing balance. On the right hand side, you see the picture of a pH meter. A pH meter always works at a particular temperature. Mostly, it would be the ambient temperature, which is 25 degrees Celsius or 298 Kelvin. If the temperature is not fixed, is not kept at 25 degree at the place where this instrument is used, naturally instrumental errors may come in. So these type of errors can be avoided by either doing the calibration or using the instrument in a appropriate conditions of temperature and pressure. Sources of systematic errors may also come from methodical errors, which is also called as method errors, that arise from non-ideal chemical and physical behavior of different systems. Sometimes you may be using a reagent which is not working properly. Sometimes the reaction that you're carrying out may not be proceeding to the completion. All these type of errors may come from different sources. As an example, we can say a common error in volumetric analysis results from excess addition of the reagent, either the titrant or small excess quantity of some other reagents, which helps the titration to go to completion. In this picture, you can find how we normally do a titration, different steps involved in the titration. We measure the titrant using the pipette and we transfer it to a Erlenmeyer flask and we add small quantity of the indicator. Then we take the analyte or the titrant in the burette and we mark the initial reading and then we release the reagent and it starts undergoing the chemical reaction, and when it approaches the end point, we observe the color change. A common error that occurs while doing a titration would be adding excess quantity of the titrant that is taken in the burette. If excess quantity of the titrant is added, then intense color of the indicator would be noticed, and when a student repeats it again and again, then method error comes in. So this type of error can also be avoided by closely observing the endpoint and reducing the quantity of substance added nearing the endpoint. The next type is personal error. Personal error usually occurs because of carelessness, inattention, and a person who is handling the instrument is not properly experienced. Sometimes it may also be due to the preconceived notions about the experiment. Many measurements require personal judgments. Examples include estimating position of a pointer between two scale divisions, the color of a solution at the end point of a titration, or the level of a liquid with respect to graduation of a pipette or burette. The universal source of personal error would be prejudice. You may have a preconceived idea that the titration would go to completion at a particular volume, so you may be adding the titrant at a faster rate. So you accidentally or with much impatience, you proceed the titration and it crosses the endpoint. So this is a personal error due to complete carelessness and impatience. These type of errors can also be reduced by paying careful attention. Here you see that on the left hand side there is a picture of a person who is attentively carrying out a titration, closely observing the endpoint. On the other hand, we find a student exhausted after working a long time. He is dozing off in the laboratory and missing whatever experiment he or she is doing. So careful attention and patience inside the laboratory is very important in reducing personal error. And no amount of prejudice or preconceived notions should be kept while carrying out an experiment. When you do not have any type of errors that we have seen earlier, all of them are categorized as determinate errors. In other words, they are also called as systematic errors. If you cannot categorize a type of error under these categories, we put them under a separate category that is called as random or indeterminate error. This type of error can never be totally eliminated. Suppose a person who is studying the source of waves coming from the outer space, he may be constantly getting a background noise which may arise due to the cosmic rays. So the cosmic ray that is coming out have not been identified till 1950, and it was considered as a random or indeterminate error while observing the waves from space. Similarly, in normal experiments that you carry out in the laboratory, we may also have indeterminate errors which may not come from a method or a faulty equipment or due to the carelessness of the experimenter. Such type of errors, which you cannot categorize under systematic errors, are usually termed as random or indeterminate errors. Thank you.